Oh yeah, so this is part 3 now. So my equation was broadly correct but worth checking. So the approximate layout of the stairs, we want to find h, which is the length of the span, the length of the diagonal of the stairs. So using trigonometry, check the length of h. H squared equals O squared plus A squared equals 1500 squared plus 3000 squared. That gives you 3354.101. Now, because I was just double checking, the so I thought let's check that answer against one step, because the lines on the diagram aren't, when you look at their diagram, as I was saying, the lines don't really, it doesn't seem to me like it's very precise, but so let's check this against a single step. The step is 260 wide by 150 high, so we're using trigonometry again. T equals 260 squared plus 150 squared equals 300.1667. So T is equal to the square root of 67,600 plus 225,000 square root. Tan alpha equals 150 over 260. So I haven't bothered to work them out, but that's you could do that quickly if you had more time. You could just double check. So basically what I found out was the length of one step diagonal is 300.66. So 10 steps is 10 times 300.1667, and so that doesn't tie up with the value of h that I got, but I'm just going to use that one because that'll be more loading, because if I times it by 10 then it says the length is 3001, whereas here it's got 3300, so I've got 10 steps within 3 meters, which is more, so I'm going to go on the safe side. So the UDL from the stair steps is 4.68, which is the total weight times 1000 divided by 3001.67, so it's either 4.68 divided by 3, which is 1.56 kilonewtons per meter. So that is for 1 meter wide staircase per meter run. So that's just because we need the UDL to design we've got to design the stairs like a beam in the second stage. So this is just the solution diagram of the result. We got use 3001 as single step, and so there's going to be this load from the dead load and this load from the low load. The volume of one step V equals 0.0195, so 10 of them is almost 0.2 meter cubed, and so we found the weight of the steps is 1.56 kilonewton per meter. Now all we've got to do is find the volume of the waste, but that's even easier. The volume of the waste is not, the thickness of the waste is 140 millimeters. T equals 0.014 meter, the width is 1, so V equals 0.14 times 1 times 1, which is 0.14 meter cubed per meter run. The unit weight of concrete is 24 as above, so the weight of the waste is 0.14 times 24, that is equal to 3.36. So if you want to double check it quickly without using a calculator, you can just do 0.1 times 24 plus 0.04 times 24, and 0.01 times 24 is 0.24, so it's 0.24 times 4, which is not 0.96. That gives you 3.36. So this is the final bit of it. The unit loads for the stairs are the dead load GK, the stair waste is 3.36 kilonewton per meter, the stairs tread is 1.56 kilonewton, so the characteristic dead load on the stairs is 4.92. The live load on the stairs is 2.5. There's no other live loads or anything. So the characteristic loads on the stairs are 4.92 GK and 2.5 QK. So it says find the factor loading on the stairs. The safety factors are gamma D for dead load 1.4, gamma L for live load 1.6, GK equals 4.92 and QK is 2.5. So therefore factor load is 1.4 times 4.92 plus 1.6 plus 2.5 times 2.5. 1.6 times 2.5 is 4, and 6.88. That gives you factor loading of 10.88 kilonewtons per meter. So that's basically it. There was another way of checking it. You could check the, which I was thinking of putting that in, but it's only if you've got more time, you want to double check it. You just do because the area of a triangle, if you just take half of the B, then it will be the same as having a solid layer of concrete on top of it. So you could just take yeah, I will maybe do that in the next video, but for now we got the answer we wanted. It's 3.36. So the loading is 10.888 kilonewtons per meter on the factored loading. So that should give you 6 marks. Maybe it's 4 for the. Maybe it's even 5 for the dead load and 1 for the live load. But that's it. Thanks for watching, and yeah, please tune in for part 2 of this one, where I'm going to do the design of the reinforcement. But that's how you get the loading on the stairs. You just got to break it up into the steps, and the only difficult part is breaking it up into the step section and the tread, if you like, and the waist. So there's nothing really, very simple, really. Only takes a couple of minutes just to work it out. So hopefully you found this useful. Please tune in for the next one, where I'm going to design the reinforcement. Thanks for watching.